Hello and welcome back to another episode of Josh's Engine Rehab. Today, I have a very special episode for you, and we are going to talk about, the rabbit hole, the wonderful rabbit hole that engine building is. And we have something real special here. This is a set of All Pro LS7 heads. And if you don't know, this is almost damn near top tier. And if this isn't, I don't know what is, because these things cost almost $9,000. Look at this. Celadine valves. On this channel? No way. Not in this garage. I am way too damn low on the totem pole to be able to work on this madness. Look at that beautiful thing. And by rabbit holes. Josh, what could you mean? There's levels to this. Serious levels to this. I work on a lot of LS7s. I know a little bit about these things. Trust me, there's always a man who can swing his manhood just a little bit harder than you. You know, he probably has deeper pockets also. So let's start here. This is a very budget-friendly Texas Speed LS7 head, or a PRC cylinder head. And you might think, Josh, why would you spend $9,000 on a set of cylinder heads when you can spend $25,000, $3,000? Get yourself a good set of PRC heads and throw those on. You'd be good to go. Everybody's happy. Actually, I think these were a little bit more expensive because they have their house-branded titanium valves installed, but that's beside the point. Even if they're $4,000, that's still less than half of what these All-Pro beauties cost. They're not the same. They may look very similar. You know, chamber shapes are basically one-to-one, right? There's some subtle changes. You know, it's a little bit more laid back above that plug. You know, the valve job's just slightly different. This has a 45-degree seat. This has a 50-degree seat. The blending's just a touch different. The porting's just a touch different. See how this has a full guide? This All Pro has a nice full length valve guide. The valve guide in the Texas Speed head, it's been cut off. In fact, it's been cut off at almost a 30-degree angle. Look at that. That's quite interesting. You'll notice that the All Pro head, the guide's been ground into, but it's not any shorter than it would have been from the start. Then you get to start looking at the subtle differences in the castings. And I've watched these castings change from year to year. These are made in America. They claim these are. I don't know that for a fact. I'm sure that there's some regulatory shadery going on there. I'm not sure, but for the longest time I've been under the impression that these were import castings. I think they may be machining the castings in-house, but at the price that they're sold at, I find it very hard to believe that they're getting these castings from the USA. The details matter. I really don't care where the head comes from, where the casting comes from. If it's a good casting, it's a good casting. So how do we end up saving so much money buying these castings? What is the difference? Part of it is going to be the parts. And again, there's levels to this. There's probably a great situation for these heads, and there's probably another situation where you would want to use these more high-end, more expensive castings. The place where you would start are the parts. This is the intake valve out of the Texas Speed heads. There's no branding on it. There's a part number on it. That doesn't go to anything. This is a house-branded valve. What's that mean? Well, these are imported from overseas, more than likely, probably from a valve supplier. Most valves come from Argentina. So probably some factory in Argentina manufactured these valves in bulk for Texas Speed. Is there anything wrong with that? Not necessarily, but there's no traceability that you would be able to obtain on where the valve came from, how it was made, and, you know, I would be very weary about using this in a lot of situations. On these heads, I'm going to be swapping these valves for a custom Ferrea. Not necessarily because these valves are junk. I'm sure they work great. They wouldn't be putting them into their cylinder heads if they work great. But for the application these are going to be used on, these aren't going to cut it. Now, with these All-Pro heads have these very fancy Celadine titanium valves. Dimensionally, these two are very, very similar. But what's the difference? This thing was probably around $100. I'm sure to Texas speed, they cost about $55 to $60 a piece. Okay, I might be a little off, but I'm sure that's pretty close in the amount of quantities that they'd be purchasing at. Now to All-Pro, these custom Celadine valves, I bet these cost All-Pro somewhere in the realm of $140 to $160 a piece. That's quite the difference. You know, and if I was to purchase these valves would probably be about $180 to $200 a piece. Big difference. Very big difference. And I'll show you all the little details that matter. Now, ignore the length situation. I want you to take note at how long these valve tips are. I would say, without measuring it, that's about a 1/4 inch long. Notice this valve tip is significantly taller on the Celadine. The reason for that is on a titanium valve, you really have to have a hardened tip. Most of the time, and this is how GM did it, you're going to have a lash cap on top of the valve. This has a steel insert on the tip of the valve that's pressed into the valve. You don't have to worry about a lash cap. It's nice to have. That's a very simple thing. A lot of people argue hard tip versus lash cap. At the end of the day, it's a nice feature and I love seeing it. You're just not going to get that on a less expensive valve. Now, just so you see, this is a lash cap. Very, very cool, very simple, great concept. I use these every single day. Okay, there's nothing wrong with this. And some people argue that lash caps are better. Some people argue that hard tips are better. I'm sure they have a time and place for both. But it's less expensive to use lash cap than it is to set up a valve to take a hard pressed and tip. So that's another cost savings. Now I want you to see and pay attention to the surface finish of these valves. Here's your inexpensive valve. Here's your expensive valve. Look at the difference. See how much lighter, more dull the surface finishes of this inexpensive titanium valve is compared to the shiny, reflective, smooth finishes on the more expensive one. They had different finishing processes after the valves were ground. The cheap valve was tumbled and then it was coated. Just in a simple rock tumbler, it does a job, which is to deburr all the edges on the part. But when I zoom in, you can see that there's a roughness to this. Okay, it goes away when we get to the valve stem. So the valve face and the stem, or the undercut on the valve, back of the valve and past the stem, they have a nice machine finish. But the part that actually rides on the valve guide has some roughness to it. Then the valve is CRN coated. These are not the same as the GM LS7 valves, but what GM got in trouble with was the valves had a little bit too rough of a surface finish on the stems. Effectively, with this hard CRN coating, which is a surface treatment or a PVD coating, that valve stem ended up turning into a file. Now that rough surface on top of this very hard coating ruined a lot of LS7s when the Z06, when the C6 generation Z06 came out, and we were finding that they were having engine failures right out of the gate. I don't like that. That's not a very good trait to have a rough finish on this valve stem. That was one of the #1 things that made me a little sketchy about these valves. Now, the Celadine valve was REM polished and then it was CRN coated. Now, REM polishing is another tumbling treatment except it uses a finer media, and I think there's a polishing compound that gets included. Everything turns into a mirror. The valves are beautiful. We're not going to have a concern about surface finishing contributing to more guide wear. Aside from my dusty fingerprints, that stem is immaculate. Both valves, they're going to serve a purpose. Believe me, they have a place. But this is what we're using in the LS7s we're going to be working on today. Now, one more thing I'm going to show you. Let me get this thing out of the way. Oh, also, the valve jobs on these heads were done on the same type of machine. They were both done on a Nguyen Contour, which is a CNC type machine. You're going to see those in a lot of higher end shops. Now, instead of using a form tool to cut the seat, it just uses a little point, just one single cutter, and then it automatically profiles the valve job. And it leaves a great finish. They don't shatter. Not any chatter that you can see with your naked eye. It's supposed to be the most accurate machine on the market today. When I measured run out on these, I measured 5 thousandths of run out. And if you've watched this channel before, you know that I like to keep my valve jobs under 1 thou. I have outdated equipment. I have a VGS-20 and I have a mill. I do both valve jobs in both machines. I can keep it under 1 thou. 1 thousandth, 0, 0, 1. I measured 5 thousandths here. How? Now, when I talk to these guys about this, they say it's because they use a live pilot versus me using a dead pilot. Now, a live pilot is the tool that goes inside of the valve guide, which centers the cutter. There's two styles. There's one that's straight, like a valve stem, and then there's another one that has a taper. I have the tapered style. They say it's not accurate, and you can't measure a live pilot valve job with the dead pilot system. I think that's a little crap, and I think we're going to do a video proving that. Just notice I pulled apart one cylinder to do an inspection. I didn't even bother pulling the heads completely apart. That was enough for me to find evidence that the heads needed to be gone through. This doesn't have any issues at all. These things came to me in pieces, parts in a box for me to set up the springs and assemble. These don't have run out problems. These things are perfect. But at All Pro, it's a smaller team. They can take more time and just individually curate every job and every cylinder head and make sure that it is to the quality that's expected out of a $9,000 set of heads. A high production company is going to turn out a lot of really high production type work. And unfortunately, what comes with that, sometimes mistakes are made. And one of the more common mistakes I see since I work on heads is valve job eccentricity or concentricity problems. I always do valve jobs in Texas Speed heads. All Pro heads, I'll check them. They're fine. They're always fine. Now, I'm not advocating for you to go out and spend tens of thousands of dollars on the best of the best parts. There are plenty of good options at that $3,000 to $4,000 mark, which unfortunately is entry level. All I'm saying is that you're more likely to find issues with these types of products. And you're just gonna have to check it, check the product, check the parts you buy, and then make decisions on what you find acceptable and go from there. 5 thousandths of run out on a seat, not cool, dude. Especially on an LS7 that spins nearly to 8,000 RPM. Now, what we are going to do today is we're going to set up these All Pro heads to spin well into 9,000 RPMs. I think we'll be spinning this engine to like 92, 9,400 RPM. And that requires a very different parts package. Now, check this dinky little guy out. This is the valve spring that came out of these Texas Speed heads. This is a pack spring. It had about 450 pounds of open pressure, about 150 pounds seated. Very good quality winding. That's their own titanium retainer. I actually don't like these. It's a cheaper grade of titanium. I think that's like a pack 1207 or a 1208. I don't know. I'm not using them on this. I want more spring rate. But anyways, that's a good spring. You can buy these for like 400 bucks with retainers, with locators, all the hardware. And what I'm using on the All Pro heads is this. This is a very sophisticated comp dual conical spring. I've got a Precision Products Performance Center titanium retainer, which is also a one-off custom for this spring. You can't buy this. This is a higher graded titanium. I happen to know what this one's called. This is a TI-17. I don't know what grade of titanium this is. It's not publicized, but I know every time I pull, oh, it just dropped it. There it is. I know every time I pull these engines apart with these heads and these retainers, they're always worn out. The Precision Products retainers, they're never worn out. But these are triple the price of these. Essentially, these titanium retainers that come with the Texas Speed kits, they're free. They have no value to them. These things, I mean, they're like 40 bucks a piece or better. And they don't wear. They last forever. As long as you don't have a Valvetrain problem, these things will go through multiple rebuilds. They're not the same. And also, I think total, this whole spring kit, it's like a $1,300 or $1,400 spring kit to go on top of the $9,000 head price. Again, they're men with deeper pockets. They can swing a lot further than you. I'm not one of those men. I drive a glorified Miata for fuck's sake. A hairdresser's car. I'm a man of culture. And I'm not shitting on my friends from Texas. We go way back. It's been many, many years since I've had them make numerous harassing phone calls to my place of employment because I said bad things about them on the internet. I'm cool. We're cool. They're cool. It's fine. They have their place. I'll use their stuff, and here I am. But I prefer this. Really. Much less headache. I have to do one thing to these. I have to modify a spring pocket, and I'll show you exactly what's involved in that. It's not bad. It's not bad. But the reason for that is, let's put these things right next to each other. Now, why would you want to use a spring like this? I mean, it's a lot of effort to go through for a solid roller spring that only has a 600-pound spring rate. And I don't disagree. You can get springs in this dimension, in this size, that will drop into these heads that have similar or more spring rate. The reason we're using this is because, one, conical springs are inherently at an advantage because of the coil design. Now, if you notice, from top to bottom, they have different diameter coils. Every single coil is a different diameter, which means that they're going to vibrate or get into a resonance or a harmonic at very different frequencies. So essentially, each coil will cancel out or dampen the frequencies or the harmonics from its neighboring coil. These conical springs inherently make for very stable valve trains. I guess quickly before I put these heads away, I'm going to show you a couple more cost savings. Now let's take a look inside of the valve guides. Come on, focus. Notice that inside diameter is nice and smooth. The guides were finished with a reamer. Take a look at my messy guide hone. Those are reamers. They roughly bore the inside of the guide, or you ream the inside of the guide. It leaves a very precise finish, but really it's very rough. There's going to be weird geometry issues with the inside of the guide bore. Is that perfectly acceptable for a valve guide? Sure. But there's further finishing steps that you can do beyond just reaming. Now the All Pro heads, Let's grab the light again. Notice something? Come on, focus. There's a crosshatch. These guides were honed. Honed just like a cylinder. So what that means, somebody painstakingly sat here and honed each individual valve guide on these heads after installing them. That is a much more time-consuming process, but the result is a very smooth inside diameter to the valve guide that also has a crosshatch that will hold oil. This guide will last longer. And I noticed something. The Texas Speedheads have CHE valve guides in them now. They never used to come that way. I'm not sure what the deal is. I swear I've seen them come with unbranded valve guides in the other platforms. Maybe they put CHE guides in the LS7 heads. I don't know, but that's new. I would always expect to see at least a CHE, if not better, inside of an Alt Pro. And I will, because it's a more expensive product. Now, another thing, these heads are set up to use stock rocker arms. That's the factory LS7 pedestal. Notice this pattern is very different because these heads were cut for a T&D rocker shaft system. Again, $9,000 heads with a $3,000 set of shaft mount rockers mounted on top of them. It keeps getting worse, that snowball. It's a hell of a thing. I need to cut these spring pockets to 1" 6/80. Most of the time you can't do that. A lot of times what will happen, and I had a really fun run-in with Massed Motorsports when I did this on a set of their heads. I called them up, and this is a short video. If you've been following my channel for a while, you've seen that short where I jokingly said, hey, I called up Massed and said, hey, can I cut these pockets without hitting the intake port? And in the short video, it sounded like I was asking them permission, apparently. At least that's what the comments said. The guys, the incels on the internet, misunderstood. What I was trying to figure out was a lot of times on an LS head, if you cut these pockets deeper and wider, or both, a lot of times this corner will end up on the inside of the intake port. And you'll end up having to weld a tiny little nub right about there. I've done that many, many times trying to put big conicals inside of LS heads. And it's just one of those things that you have to do. And with those mast heads, I just called them up and I said, hey, should I expect to hit the intake port? I mean, how close is that pocket to the port? And they said, yeah, you'll probably hit the intake port. There's not much room there, especially at the diameter you're going to cut to. But I cut it, and I cut it quite deep. And the reality was, there was a lot of thickness there. They changed the casting. It even became such a big thing that they responded to my YouTube video with a post on Facebook, a post online, explaining why you can't cut the pockets down. But I mean, I measured that thickness after I cut those pockets down. There was a lot of room. There was like 200 thousandths, 250 thousandths of thickness left in the ports after I'd cut those pockets wider as well as deeper by like another 100. So I don't know. They revised the castings. They don't want you to know that though. Thankfully, the All Pro heads have a raised pocket, or these spring pads are raised. So what that means is that these pockets can almost be infinitely modified. So there's miles and miles of material between the top of the spring pocket and the inside of the intake port. Now, you'll see that when you put the two valves right next to each other. Cameras are hard to operate, but I mean, I'm not even holding them straight. And you can see that the Acelodyne valve is significantly longer. You know, that's like 300 thousandths longer. That's to accommodate the taller head geometry. Wow, will you look at that? The more I look at these, it's actually kind of strange. These have a taller valve cover rail. But when you look at these heads, the exhaust ports are raised on the all-pro heads. Those aren't going to work with regular headers. So another expense, you're going to have a head-specific or a set of headers that fit a raised runner cylinder head. I mean, look at that. You can see the placement is just a little bit different. These are raised a little bit higher. Even the bolt pattern is just slightly higher than that one. Very interesting, very cool. But I mean, that's what you're going to get when you get into the higher echelons of racing cylinder heads in any platform, not just any LS. Though this is just any old LS, just much cooler than yours. I don't want that to sound like a whole bunch of posh snobbery, but I think we could probably add Texas Speed to the list of companies that isn't going to work with me in the future. And I think that's a cost that I can live with. Now, I don't want to sound like quite the eccentric machinist. You know, I am sociable. I can talk to another human. And one of those things that I had to talk about was like, hey, there's a few things that I'm going to have to do before we can make this modification. I'm not going to be able to just throw this thing in the machine, give you 2 minutes of action, and then say, bye-bye, I'll talk to you in the morning. Why don't you go home? You know, this isn't that kind of relationship. I actually had to spend like an hour grinding a special tool to work on these, and that was the seat pocket or the spring seat cutter. Now, it's a readily available component or tool that you can buy right off the shelf. I mean, this thing's probably older than me, but one of the traits that this thing has that it still shares with its newer counterparts, they tend to cut spring seats, which are meant to be flat with a taper, and that taper being low in the center, you know, so right here, where's my pointing device? Where's the pointing device? Oh, look at that. That's an old Oris watch head that my neighbor gave me. She said it was her father-in-law's. Manual wind movement, nothing special, but her father-in-law was a firefighter in San Francisco in the late 70s. He wore this thing every day. I think this used to have a black dial. Still runs. It's been sitting in a drawer for 30 years. Really cool. And that thing's circa 1975. Something to that effect. Anyways, where's my pointing device? Where is it? Hang on. Oh, it was right in front of me. Okay, so a lot of times these spring seat cutters, they're not straight. They don't cut flat pockets. What you'll find is they'll engage right here in the center, and then the deeper you cut, you'll see the tool path or the cutting edge progress towards the outside diameter. What that means is we're cutting tapers into all of our spring seats when we're taking one of these cutters and using them right out of the box. They're that way by design. Is that correct? No, you want things to be nice and flat, but that's how they are. Parts might not be flat, things might be a little crooked. I don't know what the deal is. I think it's wrong, but that's just how they are. I didn't want to cut these pockets deeper. These pockets were perfectly flat before. It didn't work. I couldn't move from the center out and expect to keep these things at the same height. So I sat on my tool sharpener. Let's walk all the way over there. Shop's a mess. Don't look. Close your eyes. Close your eyes. Don't open them till I say stop. I set this thing up for 2 degrees of back angle or of a relief angle. I set them up right at 0 using a parallel, and I just sat here with my 280 grit diamond, and I just profiled the underside of these cutters until I had the shape and the geometry I wanted, which was perfectly flat across both sides, both cutters at the same height. 2-degree rake or back angle. I don't know what the terminology would be. And then I sat there and sharpened them until they were sharp enough to act like a sharp cutter. That was a pain in the ass, but I mean, I won't have to do it again. This thing's done. Another thing, which isn't a big deal, the inside here, so that space between the two cutters, it's 750 or 3/4 of an inch. I need it to be 9/16, which is 562. So I had to come in with another cutter and cut out a step that I created by using this. But that's fine. I did lower these pockets by 5 thousandths. I could probably avoid it on these, but I'm just going to match the other head and cut them 5 thousandths deeper. All will be good in the world. But it's kind of interesting because, I mean, you wouldn't expect to do all this custom work. But really, that's what engine building is. I mean, the real engine building. The engine building I care about. It's not cookie cutter stuff. Custom is everything. Everything takes time. Everything has a problem, and there's a solution to each problem. And I mean, I talked these up. It's a big fancy spring. They're a lot of money. But again, I mean, there were problems with these. And I'll show you. I'm not that much of a snob, but I am particular. Notice, I'm pushing pretty hard. I'm trying to squeeze this down. Watch, that retainer is not sitting down all the way, okay? It won't go down unless I push really, really, really hard. Oh, and it made a really gross, creaky, ugly sound. And then when you look, see if I can zoom in here with my two little fingers. This is why the women love me. Come on. See that little air gap in between the top of the spring and the bottom of the retainer? That is because the inside of this coil is riding on the corner radius that was cut into these retainers. Now, Josh, how the hell do you do that? How do you fix that? What do you even do here? Most guys don't check this. This gets missed all the time. And at best, what you would see, engine goes out in service, runs, and the sharp little corner on this spring eats away at that corner radius on the inside of the retainer. That's the most ideal situation. Worst that can happen is, since we're riding on this corner radius and we're spreading this top coil, because that radius, once you get spring pressure behind it, it's going to push things outward. This isn't naturally going to ride on a round edge. You can break the spring because your retainers don't fit the top of the spring properly. A lot of people think because the spring, it clicks into place, click, that was more like a creak, but imagine that clicked. A lot of people think when it's a positive or an interference fit, that's a good thing, right? Sure, if it's a light interference fit. You don't want to have to force the spring and the parts together. That causes problems. That will break a coil. We can't do that. Not on a $40,000 engine. You know, and it's less of an issue on the outer spring, but it's still an issue. We're still going to ride on the corner radius. This would probably be fine, but let me show you. There is a spot. Let's see. See, there's still a tiny little air gap right there. Now, Josh, how do you fix that? I promise you there's a fix. And some of you might not like what I'm about to tell you, but I mean, that's one of those things that you have to do. You have to grind on the inside of the spring. And I'm not suggesting that you take your fancy little valve springs and take it to your OSHA approved bench grinder. No, no. You've got to be a little more precise than that. So this is a cheap diamond chamfer tool off of Amazon. I think it's advertised for chamfering stone or glass. I don't know what the deal is. But I thought this was a nice alternative to buying this essentially the same product or a similar product from Pack Racing Springs, which is a diamond abrasive chamfer tool. Okay, this is like 20 bucks. The one from Pack last I saw was like 100 or 120 bucks. But you'll take something like this and run it in a drill and chamfer the top of the valve spring. Seems archaic, seems a little crazy, but when you get into a level of spring above this, like a PSI, they're going to come that way. A lot of springs come that way. Sorry, I got distracted. The Hellcat people are here. Oh, it's a chick. What is that all about? Must be my neighbor's new girlfriend. I wonder what her parents think. Oh, I can feel my property values plummeting as we speak. Somebody informed the HOA. So here, I've got one of those fancy springs. This is a Manly Nex-Tech spring. Now, I've got this sitting in my junk pile. It's a memento from a better time. Back when I was building 240 horsepower Milwaukee 8 engines, circa 2017. Back when those things first came out. Maybe not exactly 240, but it was a lot. We were playing Dino Wars. It was a fun time. But this is a high quality winding. Rem polished, just like the Celadine valve. Okay, so you notice it's all shiny and very fancy. But it's not coated. Okay, that's a legit surface finishing process that was done to the outside of this valve spring. And then, if you notice, right here on top, there's a ground chamfer on the top of this spring. And I think there's one in the bottom. Let's see. Look at that. Also chamfered in the bottom. Chamfering is very common with valve springs. And that's just one of those things you do. What you don't want to do is accidentally nick one of the coils from the top to the bottom, or anywhere in between the top and the bottom coils. If you nick one of the coils in the bottom, or anywhere from here to here, you just junked your spring. So you got to be careful. And you also got to be careful about how much heat you input into the spring. If you discolor the spring while you're chamfering on it, you just junked your spring because you probably changed the properties of the coil. You know, it's not rocket science. Just take your time and be careful. It's easy. And watch me. It takes seconds. Now, I will say the Pack version of this tool, a little bit less cumbersome than this giant thing, but it serves a purpose. And it's pretty straightforward. I would say if you're careful and you take your time, you could probably do this too. But it's as easy as this. I try to push in the direction of the start of the coil. That way I can just break this sharp edge. Okay, but I mean, we've already made a decent chamfer into the top of that spring. See that? Probably want to push that way. This retainer probably drops on now. Perfect. Probably went just a little far. A little bit of clearance now, but that's perfectly fine. That's not going to be a problem. Now, let's chamfer the little spring. You can see the, whoa, focus, come on. You can see that chamfer is a lot more prominent. but this actually drops on now. Very light press, but drops on. There we go. Drops on flat. That's what you're going for. That's easy. Outer spring. Inner spring. Clicks together. Nice and stable. Nice and happy. We're not going to break any parts. Then you get your locator, and everything gets held together very, very well. The difference between a regular dual spring and this dual conical setup is these springs don't actually touch each other. Let me show you. Now here's a blast from the past. Crane cams. That's not even a company anymore. They don't exist. Harvey Crane and his legacy, just a blast from the past. Old timers, they'll remember them. I'm going to show you what the technology was 30, 40 years ago and beyond. These springs have the exact same spring rate. 600 pounds per inch of compression. This is a triple spring. This is drag race only stuff. But what you'll see, notice these coils touch each other. They'll even hold each other up without any other influence. And these center and inner springs, they're so locked together, I can't even push them apart with my fingers. Most dual springs, triple springs even, they're gonna have an interference fit going from coil to coil. Though that interference fit creates wear and it creates heat, that is how valve spring manufacturers would help dampen harmonics and keep valve trains happy and prevent you from having any valve train control issues. This was a technology that was developed. Having springs interfere with each other and touch each other is actually really good for harmonics. They're essentially dampeners for each other. With the dual conical, you don't need to do that. In fact, that would be very difficult to do just because of the very rudimentary manufacturing processes that we have, and they don't need to because, again, each varying diameter coil has its own special harmonic, its own special frequency that it's going to vibrate at. They don't need to touch. So less heat, less reciprocating mass, easier controllability of your valve train, which means more horsepower, less horsepower loss through your valve train because you're not having to have as much weight or as much spring pressure in reality as the equivalent spring that you would have in a dual. The equivalent dual spring, you would probably have 700 pounds of open pressure. And then, or even more because that spring's going to be more inherently unstable. And then one more thing, it goes without being said, that reciprocating weight. Each coil going toward the top is progressively narrower, which means there is much less weight that's actually having to move up and down. That mass adds up when you multiply this by 16 and you have a rocker involved, which then multiplies the acceleration speed of that camshaft and the cam lobe by whatever the rocker ratio is. And then like in a V8 or an LS7, that's 1.8 times. Valve gets opened at a rate of 100 miles an hour. That's a pretty reasonable set speed. Cool, I think we can handle that. But now, take that same speed, multiply it by 1.8. So now we're going to accelerate that valve opening motion or that cam lobe action by 1.8. Now the valve opens at 180 miles an hour. Okay, I think that math is right. It sounds right in my head, but I think you get the picture. The reciprocating mass is also multiplied by the rocker ratio. So with this nice light dual conical spring, that means that your valve train's probably going to be pretty happy. But when you've got a big, heavy dual or triple spring with a big steel retainer or a big even titanium retainer on top of this, things can get just a little sketchy because you might have 100 grams of valve spring hanging over the top of your probably already heavy valve. That's a recipe for disaster. That's why over the many, many decades of performance engines and Valvetrain, the name of the game was beefy and light. And you could either go all the way in the extreme one direction, or you can go all the way in the extreme the other direction. How light can you get the Valvetrain? How heavy and beefy can you get the Valvetrain? Where do you want to fall in the middle? It's complicated. I've met people who have fallen on either extreme. I have also been on the extreme of light. And I've gotten bit in the ass. What I will say is I've gone on the extreme of heavy and or beefy, much less likely to be a pain in the ass, or bite you in the ass, I should say. What that means is I've tried to go a little bit too far in the light direction, and I've gotten some things wrong. I've lightened up spring pressures to the point where I've run solid roller cam profiles with little dinky hydraulic roller springs, little single conical springs just like that, controlling a solid roller valve train. And I've done it successfully, but I've also done it unsuccessfully more times than I have successfully. So where did I land today, 2025? I like to land somewhere in the middle. I like a nice beefy valve train, but I try to get it as light as possible. That's where you land here. And that little happy medium is where I want to be. And that's what we're doing today. So here we are, we're set up in the VGS 20. I've got my custom ground seat pocket cutter, or spring seat cutter, chucked up in the drill chuck. Another point of controversy with the internet experts. Now, let's get this tool pulled out of here just so you can see. Oh, come on. Let's see if I can one-hand this. Switch hands. It's like the Stranger, but the machinist version. Let's just do that. So, a lot of people went, "Hey, Josh, you're a hack. Why didn't you grab that spring cutter, or that spring seat cutter, with a collet?" And I tried to explain to them. You try to reason with the bastards, and they don't want to hear it. They're on the internet, so of course they got to know everything, right? 3 sides. That's not round. Kind of hard to grab that with a collet chuck. These are designed to go into a Jacob style or a 3-jaw chuck, just like this. These tools generally kind of suck. I mean, they chatter. They're not very stable. You know, they make a lot of noise. But they serve a purpose. As far as a practical use is concerned, they work fine. What's going to happen, you won't be able to see it, but I'm going to cut on this side on the valve cover rail first, and then I'll just keep on running the spindle down until I cut into this casting on the outside. Now, if you pay attention to the area around the valve guide, you're going to notice that I'm not going to touch an area from about here, right up to the valve guide, to about here. And there's going to be a little tiny step left over. I'm going to have to come in with another cutter after I've cut all these spring pockets and then cut that step away. So that'll be another operation. So another added expense, a little bit more time is going to go into these heads to make them fit the application that we need them to fit. So spindle's on. I had it running just a little bit slow. I think I can turn it up actually. I've turned it up. Much better, a little bit faster. And then bring the spindle down. It should start touching now. And I hear it, you might not, but it's going clunk, clunk, clunk. Here, I have a mirror here. let's see. You can see on the back side, I'm cutting the back of that spring pocket. And now the lower I go, the sooner the rest of the spring pocket comes in. And now I've touched off on the rest of the casting. And if I'm smart, I won't stick my fat little dirty fingers into the cutting area, and I might get to keep them for a little while longer. And it's subtle, but we're making a cut. See how that all looks? A little bit of a step left. Now I should start touching the pocket. I can hear it. Now check that out. See how we are cutting on the right side a little bit more predominantly than the left side. I found that all of these heads, again, had a little bit of a shadow, or maybe I didn't talk about this, but the heads had a little bit of a shadow at 9 o'clock from the position I was standing at, so that would be right here. I checked the setup on the heads, I checked the setup on the machine, everything's nice and square. What happened is the tool path and just the way the heads were cut, it was cut in a little bit of an arc or just a touch out of square, so every head and every pocket was just low in that same position on every spot. Little observation, it's not the end of the world. It's less than 4 thousandths. It wouldn't mean anything at the end of the day, but I have seen heads where the pockets are so crooked, oh, that's ear piercing. I've seen heads where the pockets are so crooked that it wears out the valve guides. Okay, that's it. We're stopping there. And now what we're left with is just a little tiny shadow here. I'm not worried about that. The entire pocket is cleaned up. And then there's a little bit of a less than 5 thousandths tall step on the inside that I'll have to clean up at the end. Let's try that again. I did put a little bit of oil on the pilot of this cutter. The oil is just to keep from that pilot wearing out the inside of the guide. It doesn't hurt anything, but I've seen them burnish or just make the inside of the guide just a little ugly. The oil prevents that from happening. Okay, now we're about to touch off. Come on. Getting them to cut is a pain in the ass too. Sometimes chips get stuck under them. Whoa, don't do that. See that? There was a chip stuck under it. Okay, pocket's clean. Easy. Now these intake ones are a little more interesting because there's this giant wall that I'm going to have to cut through. There's some big block heads that I used to work on where I would cut a wall up on the valve cover rail in the same fashion, except it was about an inch high on one side and then just big and open area all around it. Okay, so let's cut this pocket. It's a little weird. If I feed it just a touch too fast, you'll see the handle, or I can feel the handle raise up because it deflects off of that interrupted cut. It's a little unnerving at first, but once you've made it through the interrupted cut, it evens out. So if you're a new operator, you might not understand that you'll be able to cut through that messed up section. Okay. Let's blow the chips away. Hopefully it starts cutting right away. Nope. So let's blow these chips off. Another internet expert complaint was, why do I dry cut on aluminum? They always think you gotta have lube. One of the reasons for not having lube is it would make this non-cutting action a little bit more difficult because it would be hard to cut the chips or get the chips out from under the tool. Now that I've finally blown the chips out, you can see we're engaged properly. And then it cuts like butter. It's a noisy butter, but it cuts. A lot of times what will happen with the WD-40 is it can just get real noisy, the chips stay everywhere, and it just makes a mess. Really, as long as the chips aren't gluing themselves to the cutters and causing dimensional issues or causing surface finish issues, I'm not too worried about adding WD-40 to the cut. It's one of those things, when I did the first head, I had this clamp just a little bit too close to the cutter and I almost crashed the machine because I didn't check the tool clearance. Luckily, I remembered to check the tool clearance. I wonder, oh look at that. A nice little interrupted cut here. Let's see, can you see that? On the right side, how do I hold this? Like that. Look at that. Okay. I dropped the phone, but that pocket's cleaned up. That happened fast. I may as well humor you guys. Let's grab the WD-40. I just want to show you. It's going to make it look like crap, I swear. It'll probably cut great, but it's going to make a mess. We'll move over to this hole and see what difference WD-40 makes. Also, this stuff is messy. Wear PPE. That means face masks and, you know, dust control and whatnot. All right, there's the WD-40 hole. Let's give it a shot. It's probably gonna cut great. Aluminum tends to cut better when there's lube. It's unnecessary though. It just makes it harder to clean. So I'm still just skidding off of the bottom because there's a chip stuck under the cutter. And now as I blow on those chips to clear them, look at that. The result is exactly the same. I mean, come on, point proven. There's a time and a place. You don't have to cover your part in oil just to be able to cut it. It just makes it harder to clean. I had to brake clean this to be able to get it clean and dry enough for me to even be able to display this on video. But this one was cut with no lube. Dry. Okay, it's a good finish. A little bit of chatter. Nice dull white silvery tinge to it. Now this is the one we cut with WD-40. It's a very, very slight improvement. Still chattery. That same color is now turned into a light silverish glimmer. It's a little shinier. It looks good. I don't think the juice is worth the squeeze. It's just more mess for me to clean up, and then when I go to blow that off, I mean, I suppose I could vacuum the chips off, which I do at the end. I don't leave these chips here. Okay, that was another comment. People are ridiculous. It's just the WD-40, if it's unnecessary, and I spray it all over the part, it ends up all over the machine, then I have to wipe it off. It's a preference. Now, let's see how quickly I can blow through the rest of these spring pockets. And I don't know what's playing in my ears right now. I swear it's a Young Jeezy and Kendrick Lamar collab. I don't think so. I could probably check my phone, but we're filming. What is going on here? Perfect. So I explained using that original cutter we used. I modified the cutters so everything cuts perfectly flat. And if you remember, these cutters come with a slight taper built into the cutting edges. So they come to a point something like that. This is unmodified. It's exactly as it came from the manufacturer. And these things come from different places, but they're all built by the same guy. This one happened to come from Comp Cams. They come in many different brands. They're all the same. That taper built into the tool geometry is going to play in our favor because I'll be able to just cut away that step that we created on the inside of the spring pocket that's preventing our spring locators from sitting down flat. This is you. This is the guy your girlfriend said not to worry about. Feel insignificant. So back to it. I pulled the pilot out of the old spring pocket cutter. I've got the new one. It has the original tool geometry. The way these work is real simple. There's a little flat here. That is what this set screw on the inside of the cutter body, that's what that set screw engages with. Then you just run it down until you are inside of the recess. You know you're inside of the recess when you run the screw down and you can't pull it in and out. And you just give it a little clamp. Then from there you can run it in a hand drill or inside of a machine if you've got the equipment. All right, let's get this done. Wrap this up. Okay, that's good enough. These tools weeble wobble right out of the box. There's nothing you can do about it. Put a little bit of oil in that shaft. Always lube your shaft, kings. Since there's so little tool engagement, it's not going to chatter. Shouldn't. You're going to notice, watch that inner edge. You're going to see it start to feather outward. See what I mean? In fact, I didn't really cut all that straight. But there's no more step. When I try to scrape it, the cutter or this screwdriver, it runs right across. And I'm not catching any edges, so that's done. Literally took seconds. One of the kids at my old shop, he was complaining about how one of his coworkers, someone above him, he's going through a rough time, and he just didn't register with him. And the kid said, he goes, "This guy just trauma dumped on me. I don't really care. I don't want him doing that to me." And I told him, like, "Hey, listen, dude, kind of not your place. Maybe you just need someone to talk to." So, he told me the reasons the guy was having his coworker was having a hard time. There were legit reasons. The dude's going through it. The reality is, everyone's got a different circumstance. Everyone's got a different perspective on life. What's an emergency for one person is really not a big deal for another. I won't knock a guy for saying he's having a tough time, even if I thought I would be able to handle it in stride. We're not all the same. Guys, it's okay if you struggle. All I have to tell you is, like, hey, if you're having a tough time, you should try talking about it. You don't have to carry the weight of the world on your shoulders. So today, I told the guy, I don't know him well, but I told him, like, hey, you got friends here. If you're feeling overwhelmed, you should talk about it. So he tells me a little bit. He goes, "Yeah, well, of course I'm not doing good if I have this and that happening." I'm like, "Yeah, I know. I heard. That's hard. So if you're having a hard time, talk to somebody about it. It's cool. You got the help." So it's just a reminder. Sometimes you can need a reminder. It's hard to. It's too easy to try to be Mr. Tough Guy. You don't have to be Mr. Tough Guy. I think I'm still in time for Men's Mental Health Month. And that young kid, he'll get it. Eventually he'll get it. I don't knock him for being annoyed. That's such a young kid thing. Young kid as in the guy's like 18. Okay, so all those pockets are cut. I hate these tools. They're really not all that accurate. I think part of the problem is with this was the bore wasn't very straight. So when I touch off, it would cut on one side, and depending on how much pressure I put onto the spindle, it might have cut it a little uneven. But generally, these pockets are pretty flat. I'm happy with how that turned out. So it'll be fine. So let's get those chips vacuumed up and get these heads cleaned, and I can start doing some assembly. Oh, so much crap. All right, vacuum, done. Cool. The point is, we were able to demonstrate that weird tool geometry. So it cut in the center first and was starting to make its way outward the deeper I cut. And that's why you see it start progressing. That second cut started to progress outward the deeper I cut. So just weird. Never realized that I was doing that to spring pockets for years until somebody pointed it out to me. I've only corrected it a few times. It's really not that big a deal. It's a few thousandths from end to end, but a few thousandths is enough to make a difference. Well, I would say it's getting just a touch late here. Oh man. Why do I always film videos in the middle of the night? I should be sleeping. I've got a nice, ow, screw you. I've got a nice air conditioned house right on the other side of that door over there, yet I decide I want to sit inside of a hot, muggy garage with an air conditioner that's barely been able to hold up and keep up with the 90 something degree weather. I guess it could be worse, but all right. So I'm going to get this head pulled out of here. We'll get it sonic cleaned, get it on the bench. We'll wrap this up. And before I forget, spring locator fits in the pocket. Let's find a valve spring. All right, there's a valve spring. Perfect. Walk, walk, walk. Nice. That's kind of beefy. Fun fact. I did a Ford 289, all iron. Okay, iron heads too from the 289. Actually, no. They had GT40 heads off of an Explorer. I ported them, put some nice LS valves in, did a custom little valve job, nice combination. We used those springs. I'll see if I can find some pictures, but I cut these spring pockets so large that part of the spring locator actually rode over the core plugs or the pipe plugs that sealed coolant. It was kind of crazy seeing that. I'll see if I can find that picture, but it was pretty crazy seeing how that giant ass spring packaged inside of a tiny little 289. But that engine that spun to like 82 or 8400 RPM, and out of 290 or out of 289 inches, or a little bit larger than that. It was like 291 or whatever. That thing made 474 horsepower and rev to 8,200 RPM with a very special hydraulic roller using those springs. It was pretty interesting, and that was for a of the time GT40 race car, and it raced in a spec series. That's a great spring. It's a lot of work to use it, so it's a commitment. So, story time. I'll see if I can find a video or a picture too and include that. But one of those notches in my belts. Oh, actually, that was the intake port out of that 289. That was a GT40 head casting. You can see that valve job ran right up to that spark plug hole. And I used a guide liner and bushed the guide down from 11/32 to 8 millimeter. Very, very interesting. That's one of the nice things about where we live. You can be anything you want. You can do anything with yourself. You're never stuck. There might be some growing pains involved with it, but you can do anything you want with your life. You can change your circumstances. Oh man, really overworking these Chinese sonic cleaners. A lot of fun. I'll have to flip this 180 both directions. It's about 4 setups to get this thing clean, but it does work really well. I make do with what I've got. It works out fine. I would like to have a seat, and I don't know where one is. I'm going to learn how to service that. This really interests me. I taught myself how to do everything else. I could teach myself how to do that. That's it. Now I've just got to get these heads assembled. I might stay up and get this done tonight, but It's the weekend. It's Friday. I've got to get this video edited and put up anyways. These were just a little bit too cool. I couldn't just leave without showing you the finished product. It's a whole lot of springs stuffed into not very much space. Thanks for watching. Have a good night, everyone.